Assalamu alaikum wa rahmatullahi wa barakatuh. Today we are looking at the photoelectric effect. Now, the photoelectric effect has to do with what happens when light falls onto a piece of metal. Is the light that has a certain amount of energy, is that energy absorbed by the metal, or is that energy used to eject electrons? So to begin with, we just need two important terms to look at, and when we understand the terms, we can perhaps understand the photoelectric effect a little better. The first term to remember is called the threshold frequency. The threshold frequency is the minimum frequency of light required by this particular light to eject an electron from the surface of the metal. So if a particular light, for example, red light or blue light or green light, they all have certain frequencies. If the frequency is enough to give that light sufficient energy to eject an electron, then that frequency will be called the threshold frequency. Another important term is the work function. The work function is the minimum energy required to eject an electron from the surface of the metal. So each metal has a different bonding between the protons and the electrons in the metal. And so because some metals have a greater attraction of the electrons to the protons, they will require more energy than others to eject an electron from the metal. Now let's look at a specific example. If you look at this example, we see that red light is falling onto sodium metal, and the sodium metal has a work function of 3,6 times 10 to the minus 19 joules. So that means that the work function of the sodium metal is the amount of energy required to eject an electron from the sodium metal. Now, we're not doing the calculations here, but we see that red light has a frequency that is less than the threshold frequency. So when red light falls onto the sodium metal, we see that no electrons are ejected. No electron is ejected. The reason being that red light has the energy that is less than the energy required to eject the electron, which is your work function. So because the red light is below threshold frequency, it doesn't have enough energy to eject an electron. So all that energy that's given to the metal will be changed to internal energy. It will just make the metal a little bit warmer, whatever the case may be. Now, if we have a case where the frequency is at the threshold frequency, for example, in this case, the green light. So the green light has sufficient energy to eject an electron. So we can say the energy of the green light, which is given by the equation E is equals to hf, where h refers to Planck's constant, which is 6,63 times 10 to the minus 34, multiplied by the frequency of the green light. We are given the wavelength and not the frequency. So we won't work it out, but multiplied by the frequency of the green light, we'll see that the energy that's given here will be similar to the work function, or it will be the same as the work function of the sodium metal. So when green light falls onto the sodium metal, it provides sufficient energy to eject an electron from the surface of the metal. That's why we see the electron is here at the surface of the metal. So that frequency which is sufficient to give, that frequency that has sufficient energy to eject an electron, that frequency is called the threshold frequency, which is given by F0. So this E is equals to HF in this particular case can be written as W is equals to HF0. So these two are the same in this example. Now, going further, what if we have a higher frequency? We see that violet light has a greater frequency than green light, which has a greater frequency than red light. So because violet light has a greater frequency than the threshold frequency, it basically provides more energy to the sodium metal than green light. So the energy that's given off in this case is written as HF but we see that we are also given extra kinetic energy, because here we see the electron is moving away with particular kinetic energy from the surface of the metal, Ek. So the energy that's given to this can be written in different forms. One is equals to E is equals to HF. HF0, as we saw in the previous example, HF0 can be written as the work function, which is your minimum energy, which is W, and it can also be written as W0 plus Ek. So the energy that's provided to this metal is the minimum energy required to eject an electron plus the kinetic energy given to the electron. So this is a summary of the photoelectric effect. So to look at it again, if your energy is low, if your frequency is lower than your threshold frequency, then nothing happens. There's no electron. If your frequency is at the threshold frequency, then the green light has sufficient energy to eject an electron at the surface of the metal. And if your frequency is greater than your threshold frequency, then this particular light has enough energy to eject the electron and to supply the electron with excess kinetic energy. Now, if you look at the data sheet that will be given at the end of the year, we see that these are the equations that we'll use. E is equals to HF, or E is equals to HC over lambda. The C over lambda will be the same as F, where C is the speed of light. Alright, so we could use this equation, E is equals to HC over lambda, to work out the energy of the light that's falling onto the metal, or we could use E is equals to HF, and if the light is greater than the threshold frequency, so for example in our case we have violet light, then we will say the energy supplied by the violet light is equal to the energy that's used to eject the electron, and the excess is given as kinetic energy. So this is a summary of the photoelectric effect, and I think this diagram is very important. I just want to mention that the colors of light don't have to be red, green, and violet. We are just using lower frequency, threshold frequency, higher than threshold frequency. Lower frequency, no electron is ejected. Threshold frequency, electron ejected onto the surface of the metal. Higher than threshold frequency, electron ejected with additional kinetic energy. Just one more thing. I just want to even mention that if, for example, two rays of light fall to on a metal. So in this case, what we are doing, we are increasing the intensity of the light. So instead of one ray of light, two rays of light are falling. So if we increase the intensity of the light, then if two rays fall, two electrons are ejected. That's an important point to remember. So if we increase the intensity of green light, there will be two electrons that are on the surface of the metal, or more, depending on how many rays of light are falling onto the metal. If we increase the intensity of the red light, no electrons will be ejected. So increasing the intensity of the metal will just increase the amount of photoelectrons that are striking the surface of the metal. It doesn't provide more energy to eject electrons. So this is a basic summary of the photoelectric effect, and I hope that this makes things clear for you. Thanks.